Right, in this video we're going to look at goal 4 of the System of Equations and Matrices unit. This will be the last goal for this unit, so it's on performing matrix multiplication. So in the last one we looked at how to add matrices together. This will talk about how to multiply them. There are two different types, and we'll just look at how to calculate them. So the first one is called scalar multiplication. And what's a scalar? Well, a lot of this stuff is used in computer science and physics. As you can imagine, it's a big array of numbers. So unfortunately, due to the constraints of this online learning stuff, we don't really have time to look at all the applications of it. I'm just showing you it in case you go to a college class and you have to do it, or somebody brings these up. At least you've seen them before. So I won't go over the applications, unfortunately, but there are applications of this. A scalar, if you've taken like physics, it's something that literally scales something. It basically multiplies everything. And a lot of these matrices can represent like directions in space and vectors and things like that. So if you've encountered those, great. If you haven't, those are things that they would apply to if you ever hear about them in the future. So this says, what is a scalar? A scalar is just a single number that multiplies a matrix. And it's called a scalar because it's scaling the matrix. It's like doubling its size or tripling it or whatever. So a kind of problem that would have scalar multiplication would have any size matrix in it. So it doesn't matter how big the matrix is. All that matters is there's that single number out there. The single number can kind of be thought of as a 1-by-1 matrix, but they don't bother with a single number to put the brackets around it. So they just put the 2 out there. And if you want to do scalar multiplication, it's very simple. As long as you can multiply, you just take this 2 and you double every single value. So whatever number's out here that's the scalar, it just multiplies into all the values of the matrix, and that gives you your result. So if I just take this 2 and multiply it by each number, I get this result. I'll get 2, 4, 10, 6, -2, and 0 stays 0. So scalar multiplication is that easy. If you see a number in front, multiply all the values, and just write the same size matrix with that number multiplied all in, and you're done. Once again, it doesn't matter the size of this matrix. If this thing had 25 entries, I'd do it 25 times. If it was just, maybe one column, I would just do it to the one column. So hopefully the problem's on the homework. You'll see the number, just pop it into the matrix and multiply everything. The one that's a little more difficult is when you want to do matrix multiplication between two actual matrices. So to multiply two matrices, meaning that you actually have a certain dimension to one, a certain dimension to the other, they're both arrays of numbers. This rule has to be followed. So the only way you can multiply matrices is if the number of columns of the first matrix is equal to the number of rows of the second. And it's probably easier to see that in the letters down here. So basically, you can have two different size matrices. I'm just using general letters here. So this is m by n, and then this one's n by p. The key thing here is that these two match. So basically, this is the rows and the columns of the first one, and then this is the rows and the columns of the second one. So the columns of the second one, the columns of the first one have to match the rows of the second one, which is what's saying in there. Now, if that's true, you can multiply the matrices. If this isn't true, so I'm going to show the problem, I'm going to write their dimensions. If these two don't match, you can't perform the multiplication. It's kind of like when we were doing addition, you could only add matrices that were the same size. In this, they don't have to be the same size, but they do have to have this number and this number match. Okay? If these two numbers match, then the answer matrix actually comes out m by p. So the new matrix will have this many rows and this many columns. And what I'm going to show you here is how do we calculate that? How do we take two different size matrices? When we guarantee these match, how do we then fill out the new matrix with its answers? All right. So I'm going to show the two examples without doing them. I'm just going to let you see them because I'm going to have them on the board in the back. So the first one I'm going to do is going to come out a little large because this is a 3-by-2 matrix. It's got 3 rows and 2 columns. This one is a 2-by-4 matrix. It's got 2 rows and 4 columns. When I write it out, you'll see that it fits the criteria that we want. Basically, this one's 3 by 2, this one's 2 by 4. We're going to get a 3 by 4 matrix for its answer. And how do I know they're multiplying them? Well, just like other things in math, if they're next to each other, this matrix next to this matrix is basically telling us multiply them together. So I'm going to get a 3 by 4 matrix with a whole bunch of new numbers in it. I'm going to show you how to calculate that. It's a little weird at first, but once you get the hang of it, it's just kind of a bit calculator intensive or calculation intensive. You can do it without a calculator, but you just got to go through it. All right, so before I go and show you that, I'll show you the second example and then get the laptop here out of the way. This one is got a 2 by 3 matrix and then a 3 by 2 matrix. So since it's 2 by 3 and 3 by 2, the 3's match, I will get a 2 by 2 matrix over here for its answer. So the new matrix is has its own size. It is based on the originals, but like loosely. So in this case, I will get a smaller matrix than I got in the other problem. All right. So from here, it's just a matter of, well, what exactly do you calculate? So I'll go slowly for the first one or two of them, and once hopefully you get the idea, I'll pick up the pace and fill out the answer matrix, and hopefully you'll see how to do that. Okay, so let's get this out of the way. And so here's that first example. And I showed kind of the work on the bottom that you would want to check. There's a 3 by 2 matrix. There's a 2 by 4 matrix. I have these here, just go, look, these match. So therefore, if these match, I can perform the multiplication. I'm not going to give you one that doesn't work just because I don't want to load up the homework. You know, I've been told to keep them light. But if these didn't match, like if that was a 2 and that was a 5, you'd go, can't do it, you know, no answer, move on. So for both these examples, and when you get on the homework, these will match. So then you go to these and go, okay, well, what should my answer look like? It should be 3 by 4. So what I wrote here is, well, 3 by 4 matrix, and I started to prepare my answer. So I made a matrix. I gave it 3 rows, 4 columns. I just put some dots there. I mean, the dots are just placeholders. Each one of those spots needs a number. So now, how do you get that number is the question. Well, where the number comes from is what you're going to do is you're going to take the rows of the first one and multiply them by the columns of the second one. So the ones that match in size. So I'll circle them here. So there's the row of the first one. There's the column of the second one. So now what do you do with these? You basically match them up. You go, well, I want to multiply the row by the column, and I'm going to place the answer. And I put the math down here. But what you do is essentially take these two things and sort of turn it over. So the first one goes with the first one, the second one goes with the second one. So if I match these, the 2 goes with the 3 and the 1 goes with the 4. You multiply the numbers together that land on each other. So 2 goes with the 3, the 1 goes with the 4. So 2 goes with 3, 1 goes with 4. You multiply them, and then you just add up your total. So 2 times 3 would give me 6, and 1 times 4 would give me 4. Once you get each one of those multiplications, you multiply them and then add up everything that you get, and I get a total of 10. Now, where does the 10 go? Well, the 10, because the first row and first column were used, I'm going to put it in the first row, first column of this matrix. So this number 10 goes into the first row, first column of the matrix. So now what do? Well, I keep doing this. I go first row, second column. So I'm going to use that 2, 1, but now I'm going to go on to the second column. So I'm going to use first row, second column, and I'm going to do the same thing. I'm going to take these two numbers, sort of think of matching them up. So 2 is going to go with 0, 1's going to go with -1. Take these two, match them up, and then here's the math. I'm going to do 2 times 0 and 1 times -1. So once again, if you follow my fingers here, 2 goes with 0, multiply them, 1 goes with -1, multiply them, and then add up the result you get. So 2 times 0 is 0, 1 times -1 is -1, and 0 plus -1 is -1. Now, since the first row, second column was used, I'm going to put the result in the first row, second column, which is right here. So this is the second entry of the matrix. Now, this matrix needs 12 entries, so I need to keep doing this. So now that I've explained the first couple, I'm going to kind of do it faster because I could do a lot of this, and you probably could too. Most of you could probably do a lot of these simpler calculations in your head. Just keep in mind, I'm always using the rows of this and always using the columns of this. I am not using these columns and I'm not using these rows. All right, so as I go across, I'm going to keep going rows of this, columns of this. So if I continue, I want the first row, third column. Well, I'm going to do the same thing. Take the first row, match it with the third column. So I'm going to get 2 times 4 and 1 times 1. 2 times 4 is 8. 1 times 1 is 1. 8 and 1 is 9. So then 9, since it was the first row, third column, should go there. And now the way I'm going to get the first row, fourth column, is to take the first row over here. So take these two and match them with the last column, the fourth column. So I have 2 and 1. So the 2 goes with the 6. That gives me 12. And the 1 goes with the 4. That gives me 4. So 12 and 4 is 16. All right, so I've finished that first row and I've done every column. So what do? Is I do it again. I take the second row. I don't know if I have another color here. Let's find another color. I would basically take this second row and do it again, right? So I'm going to go second row, first column. And that's going to go into the second row, first column. So what do? Is I take that second row, the 3 and the negative 4. I'm actually going to match it up with the 3 and the 4, right? So 3 times 3 is 9. Negative 4 times 4 is negative 16. 9 minus 16 sounds like negative 7. So that's what's going to go here. And once again, I'm putting it there because the second row, first column, when I do that math, it gives me the entry for the second row, first column. So let's keep going, and hopefully I don't make a mistake. If I do make one slight error or something, just realize what I'm doing, because like I said, I don't have an answer sitting in front of me, so I'm going to try not to make any calculation error. But if you get the idea, if I do, like I said, just forgive me. So now I'm going to do the second row. I did second row, first column. Now I need to do second row, second column. So I'm going to take the 3 and the negative 4. 3 times 0 is 0. Negative 4 times negative 1 is 4. 0 plus 4 is 4. So I'm just doing this calculation I did in the beginning. It came from the second row, second column, so it sounds like 4 goes here. And I'm going to keep going. So I'm going to go a little faster now. Hopefully you get the idea. Because if you do get the idea, it doesn't need to take this long. You can just kind of blast through it. So I'm going to take the 3 and the negative 4. 3 times 4 is 12. Negative 4 times 1 is negative 4. 12 and negative 4 added together is going to give me 8. So there it is. And then I'm going to do the second row, last column, and put it here. So once again, the 3 times 6 is going to give me 18. Then I'm going to get negative 16 and 18, and negative 16 should give me positive 2. And now I'm going to take the last row and put it with the first column, and last row, second column, and fill this out. So basically it's like doing every combination of rows of the first with every combination of columns of the second. So let's finish it off. The 4 and the 2 are going to pair up. So the 4 goes with the 3 is 12, and the 2 goes with the 4, which is 8. So I'm going to get 12 and 8, which put together is 20. So 20 goes here. Oh, that's really bad. That's a little better. Last row, so notice it was last row, first column, went into the last row, first column. Last row, second column. 4 times 0 is 0. 2 times negative 1 is negative 2. And I get 0 plus negative 2, which is negative 2. Here I get the 4 and 2, go with the 4 and 1. That's 16 and 2, which is 18. And then the very last one, 4 and 2, are going to go with 6 and 4. So that's going to give me 24 and 8. 24 and 8 is 32. Took a little while. There's my answer. All right, so if I multiply these two matrices together, I get a matrix that's this big, and there are all the entries. They're basically obtained from taking the rows, matching with the columns, and then each entry in order. Basically, you take each entry of the row with each entry of the column and multiply them and then add the result all together. So every time you do row with column, you're getting one number, and you're placing that one number in each spot. All right. I'm going to show that second example, just hopefully you get the hang of what's going on, because like I said, this basically gives you the process, but I'll show you with two different, other sized matrices. So let's look at this next one.